Hello, and welcome to an online course for the Automate the Boring Stuff with Python book. I'm Al Swigert. I'm a software developer and tech book author. Automate the Boring Stuff with Python is my fourth programming book, and now I've made an online course that follows the book's content. Learn to code has become a huge mantra. You have sites like Code Academy and Khan Academy and massive online open courses to teach people to program. You hear things like coding is the new literacy, or how everyone in the 21st century will have to learn to code. And if you want to become a software developer, this course can be your first few steps on that path. But what if you don't want to change careers to software engineering? You're still getting these learn to code recommendations. Automate the Boring Stuff with Python is released Creative Commons license, so you can buy an ebook, or you can read it online for free at theboring.com. Is there a reason the average office worker, student, or administrator learn code? Visit website sheets. These jobs use laptops and PCs as a primary tool. And some means spending hours doing tasks that require a bunch of mindless clicking and typing. If you turn to shuffle this work off to, you should learn to code so that you could program the computer. Or if you're the intern, you should learn to code so that you can program the computer to do these for you. So how is this course different from all the online programming courses? Well, I wrote Automate with Python for people who wanted to get up to speed making small practical tasks as soon as possible. You don't need to know sorting algorithms or object-oriented programming paradigms, so this course solves the computer science and concentrates on writing code that gets stuff done. But if you are a computer science student or budding software engineer, this course will be a good first step to develop your kiddo skills. This course uses the Python programming language. Python is the best first language to learn. Many universities are switching their computer science curriculum away from Java and to Python. It has a simple syntax and a gentle learning curve, but it's still a powerful language used in the real world. Yahoo, YouTube, and even non-technology companies like JP Morgan use Python. So learning to code can increase your productivity, but it's also a creative skill. Unlike other creative skills or hobbies, if you have a computer, there's nothing else to board for code. You don't have Paint or Yarn or Power Tools. All you need is some free software called the Python. Sound good? Let's get started right now. Open a web browser. Go to Python. You'll need to download and install Python for your operating system. This is slightly different from Windows Linux, so consult the course notes for specific instructions. The one thing you should download 3 Python, like Python 3.5, and not a version 2 Python, like Python 7. When we say Python, we usually mean either the Python interpreter software that you've just downloaded and installed, or the Python language. Software comes with an editor program that Python, the language, code into. The editor is called idle. Consult notes for how to start up idle on your operating system. Beginning in the next lesson, we'll start writing code using it. Idle open and follow along with the videos by typing the examples into it. Don't just watch the videos. It's easy to passively watch the videos and think you understand the code builds your memory. See if you can get the code working. One last thing that you should know from the start. Half of a software engineer's day at Googling for information. Programming can be complicated and no one can keep all this information, so don't feel bad about constantly looking stuff up on the internet. That's exactly what professional software do every day. So if you get an error message and have no idea what to talk about, a good starting point is copying and pasting this message into a search engine. The first 3 results will probably be to a website called Slow, which is a great question and answer site. So before asking people for an answer, try the answer yourself on the web. 1, this will almost always be faster because 2, other people have probably already had it answered. But when you do ask questions, provide as much detail as possible. Here's a few things to keep in mind. Explain what you're trying to do, not just what you did. If you get an error message, specify the point at which the error happens. What number does it happen on? Does the error happen every time, or does it just happen randomly sometime? Copy and paste the entire error message and your code to a pastebin site like pastebin.com or just github.com. These websites will give you a linked text which makes it easy to share with other people you've already tried to do to solve your problem. This trims down the list of possible causes and people you've already sunk into figuring things out on your own. List the version of Python you're using. Also, if you're running Windows, Mac, or Linux, and what version you're running, like Windows 7 or Mavericks 10.9.2. Asking effective questions and knowing how to find answers are invaluable tools on your programming. Let's begin. Welcome to the second lesson. We're going to go over 3 topics in this video: expressions, data types, and variables. Go ahead and start idle, which is the editor that comes installed with Python. On Windows, click on the Start button, type idle, and I have multiple versions of Python installed on my computer, but I'm just going to use idle that comes with Python 3.5. The course notes describe how to start idle if you have Mac or Linux. Idle has 2 parts: the interactive shell, and if you click on File, New File, the file editor will appear. The interactive shell runs Python instructions one at a time and shows you the results immediately. Great for just experimenting and seeing what instructions do. The file editor lets you enter Python code for complete programs. There are other editor apps for typing in Python programs. I use one called Sublime Text, and there's another one called PyCharm. But this course will use idle because it comes with Python and there's no additional setup to do, and because it's the same across Mac, Windows, and Linux. The interactive shell and file editor windows look really similar, so it's easy to get them confused, but you can always tell the difference because the interactive shell will have the triple angle bracket prompt. In this lesson, we'll be entirely focused on the interactive shell, so close the file editor for now. Let's begin by typing a simple Python instruction. Type 2 plus 2, and then press enter. In Python, 2 plus 2 is called an expression. It's the most basic kind of programming instruction in the Python language. Expressions consist of values, such as the 2's, and operators, such as the plus. Expressions always evaluate, that is, they always reduce down to a single value. So in this example, 2 plus 2 is evaluated down to a single value 4. You can even think of the single value by itself as an expression. The expression 2 evaluates to itself, 2. There are several other types of operators we can try out. Type the following: 5 minus 3, which does subtraction and evaluates to 2. 3 times 7, which does multiplication and evaluates to 21. Note that multiplication is done in the asterisk and not the x. If you tried to type something like 3x7, Python would just give you an error. For division, we use the /, so 22 divided by 7 evaluates to 3.14. And there are a few other less common math operators, so check the course notes for them. Now, order of operation rules apply here. Multiplication and division are done first, then addition and subtraction. But you can use parentheses to override the usual precedence if you need to. So let's look at 2 similar expressions. 2 3 times 6, which evaluates to 20, and then type 2 plus 3 in parentheses times 6, which evaluates to 30. So I have a visualization tool so that we can see how Python evaluates expressions step by step. In 2 plus 3 times 6, the multiplication is done first. So 3 times 6 evaluates to 18, then 2 plus 18 evaluates to 20. Well, the parentheses overrides the multiplication, so 2 plus 3 is done first, and a value just in parentheses by itself just evaluates to the value, and then 4 times 6 evaluates to 30. No matter how big the expression is, Python evaluates it until it becomes a single value. Let's use this expression as an example. Open paren, 5 minus 1, close paren, times, open paren, 7 plus 1, close paren, divided by, open paren, 3 minus 1, close paren, close paren. No matter how complicated an expression is, all expressions are just values and operators, and it always evaluates down to a single value. You can see this step by step in the visualization tool. And 7 plus 1 evaluates to 8, 3 minus 1 then evaluates, and then the operation inside the parenthesis evaluates, and then finally it evaluates down to 16. All these expressions evaluate to the same thing. You can copy and paste any of these, and they evaluate to the same value. If you type something that Python can't understand, it'll display an error message. So let's trigger one of those in idle right now. Type 5 plus and press enter. You can always test to see whether an instruction works by typing it in the interactive shell. These errors don't damage the computer. Don't worry. Professional software developers get error message while writing code all the time, so don't think that you've messed anything up. All values have a data type. A data type is a category of values, and every value belongs to exactly one data type. So whole number values like -2 and 30, for example, are integers. Numbers with a decimal point, such as 3.14, are called floating point numbers. We also call integer values and floating point values ints and floats, for short. Note that even though 42 is an integer, 42.0 is a float. So there's also a data type for text values. These are called strings. When typing, strings begin and end them with a single quote, so Python knows where the text begins and ends. For example, type quote, hello world, and quote. And when the plus operator is used on strings, it's the string concatenation operator. Concatenation means joins the strings together. For example, type Alice plus string Bob. And this expression evaluates down to the single string Alice Bob. Less common is the multiplication operator for string replication, which operates on an integer and a string. This is handy if you have to make a string repeat itself. You can type in the string Alice times 3 to create the string Alice, Alice, Alice. Or try this expression, which uses string concatenation and replication. The string hello plus the string exclamation mark times 10. And that will evaluate to a string value that has hello with 10 exclamation marks after it. Your programs can save values to the computer's memory with variables. A variable is kind of like a box that can store a single value. You can do this with an assignment statement. In the interactive shell, enter spam equals 42. Now this creates a new variable named spam and stores the value 42 inside of it. So you can think of it as a box with the label spam and it has the value 42 in it. And normally you would give variables names that describe the data they contain. Imagine if you were moving and you labeled all of your boxes stuff. That wouldn't be too helpful. But for these lessons we just need a generic name, so the words spam, egg, bacon, and ham are often used in Python tutorials because of the spam comedy sketch from Monty Python.
Egg, bacon, sausage, and spam. Spam, bacon, sausage, and spam. Spam, spam, bacon, and spam. Spam, egg, and spam. Spam.
You can use variables and expressions anywhere you would normally use values. A variable just evaluates the value it contains. So when I type spam, that evaluates to 42. So in the interactive shell, type spam equals hello. That will store the string hello in the variable spam. Now when we have the expression spam plus world, oh, whoops. Well, Python does exactly what we tell it to, which is why it doesn't have a space in between these words. Let's try that again. Spam plus, and then world with a space in front of it. There we go. So this is just regular string concatenation because spam evaluates down to the string inside of it, and then that gets concatenated with the world string. Additional assignment statements can change the value that's inside the variable. The old value is forgotten. This is called overwriting the variable. So I could set spam to a new value, such as goodbye. This same spam plus world expression evaluates to a different value. So you can think of the old value as being tossed out and forgotten, and the new value being assigned every time we have an assignment statement. Expressions are one kind of instruction in Python. The other kind are statements. Unlike expressions, statements don't evaluate to a single value. Although an assignment statement can have an expression as part of itself. Let's try typing spam equals 2 plus 2. The 2 plus 2 expression evaluates to 4, and so 4 is the value that gets assigned to spam. We can even use the variable itself to set the variable's new value. Try typing spam equals 10, and then spam equals spam plus 1. This assigns spam a new value. The new value for spam is equal to the current value of spam plus 1. Spam, 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 variable spam. So, if a Python instruction evaluates to a single value, it's an expression. Otherwise, it's a statement. But most of us just generically call them instructions or code. To recap, idle is the editor program that you type code into. It has two parts, the interactive shell, which runs code one instruction at a time, and the file editor, where you will type complete programs into. Expressions are made up of values and operators, and they always evaluate down to one value. And every value belongs to exactly one data type. The data types we've seen so far are integers, floating point numbers, and strings. And strings contain text, and they start and end with a single quote character. And values can be stored in variables, which can then be... That's enough of the interactive shell for now. Let's write our first program. In idle, click on File, New File. This makes the file editor window appear. Enter the following code. I'll explain what it does afterwards. Pound. This program says hello and asks for my name. Have a blank line, followed by print hello world, print what is your name, pound, ask for their name, my name equals input, print it's good to meet you, plus my name, print the length of your name is, print len my name, print what is your age, pound symbol ask for their age, my age equals input, print you will be plus string int my age plus 1 plus in a year. Save this program as hello.py. Python programs are just text files that have the .py file extension. Then click on Run, Run Module, or just press F5 to run the program. Hello world, what is your name? Al. It is good to meet you, Al. The length of your name is 2. What is your age? 26. Yeah, I am 26. You will be 27 in a year. I remember when that was true. Okay, that's the entire program. One thing to keep in mind is that Python will start at the first instruction at the top of the program, and then move downwards, executing each instruction in turn. Think of it as putting your finger on the top instruction, and as each instruction is executed, moving your finger down to the next instruction. This is just like how you might move your finger along the lines of a book that you're reading. Your finger is called execution. The execution in Python starts at the top and moves down. So the first line with the pound sign is called a comment. Python ignores comments. You can use them to write notes to yourself or reminders about what the code is trying to do or what the entire program does. Blank lines are completely ignored by Python. You can just use to space out your code. In fact, let's add a couple more blank lines, maybe right here, to group together the code that's relevant to asking for your name and the code that asks for your age. The print function displays the string value inside the parentheses on the screen. So the line print hello world means Print out the text in the string hello world. Functions in Python are like mini programs in your program. They contain code that do various things, and for your convenience, Python comes with a lot of them. In code, a function is its name followed by parentheses, and optionally, sometimes there are values passed to the function inside the parentheses. In this context, these values are called arguments, but really values and arguments are the exact same thing. This is called calling the print function when we have code like this here. So the next instruction is also a call to the print function. This time it's passing the what is your name string to the print function. There's also a comment at the very end of the line. You can always add comments to the end of an instruction, since everything after that sign will just be ignored by Python. When the input function is called, Python waits for the user to type some text on the keyboard and press enter. And just like a variable will evaluate to the value it contains, calls to the input function evaluate to the string value of what the user typed. So if I typed in Al when int was called, this my name variable assignment statement would just evaluate to Al. And then the string Al gets stored inside of my name. Remember that expressions can always evaluate down to a single value. So if Al is stored in my name, then this is what that print function looks like. First, my name evaluates to the value inside of it, and then this is just a string concatenation. So the next step looks just like this. So this is the string that gets passed to the print function call. This next line introduces a new function called len. What len does is it takes a string argument and then evaluates to the integer value of the length of the string, which is the number of characters in the string. Let's just experiment with this function in the interactive shell for a little bit. So I can call the length function and pass it al, and it returns 2. Let's say Albert returns 6, or length the blank string, and that returns 0. And then I can just use these function calls to len anywhere I could use an integer. So I could say, if I typed out my name 10 times, its length would be 20. So then we have some more print and input calls. This time we're saving whatever the user types into the variable myAge. And then we have this line, which introduces the string and int functions. Now this seems really complicated, so we'll just take this one step at a time. The string and int functions return string and integer values of whatever you pass them. So this is really handy if you need to convert between data types. So in the interactive shell, you can have something like string of the value 26, and that returns a string value with 26 in it. And if you have to go the opposite route, you can call the integer function and pass it a string value like 1, 2, 3, 4, and it will return an integer value. There's also a float function that you can use to convert something to a floating point value. So if you can pass a string to it, it will return a float value, or if you pass an integer value to it, it will return a floating point version value of that integer. Notice it has the decimal point and 0.0. This may seem pointless, but remember that the input function always returns a string value, even if the string value is something like 26. And we can't do math on a string. That returns an error. First, we have to get an integer value of it, so that's why we pass it to the int function. And just like you can't do addition on strings, you can't do string concatenation on integers. So we're going to have to call the string function, convert that into a string value. This is what the entire last line looks like when Python evaluates it. First, the myAge variable will evaluate to the value that's inside of it, and then that gets passed to the int function, which returns an integer form of it. We add 1 to that integer. We have to convert that back to a string value because we want to concatenate it with the other string next to it. And then after that, it's just the string concatenations. And so all of this just reduces down to this string, which we pass to the print function call, which then gets it displayed on the screen. And that's how the entire program works. Just to recap, the file editor is where you type in code for a program. The execution starts at the top and then proceeds down, executing each instruction in turn. Comments begin with a $sign and are just notes that are ignored by Python. They're just notes for the programmer. Functions are kind of like mini programs that your program can run to execute code that does some specialized thing. In this case, the print function has code for making strings appear on the screen. There's a print function for making text appear on the screen. There's an input function for getting text from the keyboard. And there's also a string, int, and a float function that returns an integer, string, or float version of the values that pass to them. First, let me show you a kind of diagram called a flowchart. In a flowchart, you start at the start box, and then you follow the arrows to the other boxes until finally you get to the box. You can take a different path depending on different conditions. A flowchart is a good metaphor for how execution can move around your program. For example, this flowchart shows you a decision-making process for what to do if it's raining. You can put your finger on the start, then depending on answers to these yes/no questions, you can move around until finally you get to the end box. Instructions called flow control statements can decide which to learn about how to represent those, and this involves 3 things: Boolean values, comparison operators, and Boolean operators. Remember, we've already seen values and operators. Here we're just introducing the same concepts as before. Boolean data has 2 values, true and false. Strings effectively have an infinite number of different values. You just keep longer and larger and larger. But the Boolean data type only has these 2 values, true and false. Like any other value, Boolean values are used in expressions and can be stored in variables. Just be sure to type them with capital and the rest of the word in lowercase. Comparison operators. Comparison operators are used in expressions just like the plus operator and operator. There are 6 comparison operators: equal to, not equal to, less than or equal to, and greater than or equal to. Compare to a Boolean value. So let's experiment a bit in the interactive shell. Is equal to 2. This is an expression that evaluates down to Boolean value because it is, 42 is the same as 42. However, 42 is equal to hello, that'll be false, or 42 equals 1, that's false. You can also check with the not equal to operator. 2 is not equal to true, and less than or equal to 42 is less than 100, that's true. 42 is greater than or equal to 100, it's true. 2 is less than 42. Well, that's, but 42 is less than or equal to 42. Well, that's true. These are just expressions, just like those 2 plus 2 math problems we did before. That means we can complicate it as we want, where we can use variables. Let's say my age equals 6, and then my age is an expression that evaluates to true. One thing that you should notice in Python is that integers and strings will always not be equal to each other. The 42 and the integer 42, those aren't going to be the same. So even a string in it, it's still a completely different thing from any integer value. float values and integer values can be equal to each other. You might have noticed that the equal to operator has two equal signs, while the variable assignment operator just has one equal sign. It's easy to confuse, so here's a good trick for which is which. You can always think of the equal to operator as being two characters, just like how the not equal to operator is two characters, the exclamation point and the sign. There are also three Boolean operators, and or not. You might have used them in search engines, so let's do some experiments in the interact shell operator. The AND operator evaluates an expression to true, both, otherwise it evaluates to false. So something like true evaluate to true, but if one or both of these are false, then the entire expression evaluates to false. There's a concept called truth tables that enumerate every possible combination of these two values. So true, evaluate true, and otherwise it's false. The OR operator will evaluate to true if either or both of the values. As long as it's not false or false, it'll true. So true or true, true or false. The only time that it's false is when both of them are false. Here's the truth table for OR. Everything is true except evaluates to false. And then not evaluates to the opposite Boolean value. Not true is false, and not false is true. So unlike the AND and OR operators, the NOT operator only operates on Boolean value. So its truth table is fairly simple. You'll often mix Boolean and comparison operators together in the same expression. My age equals 26. My pet equals pet. Then we can have a complicated expression like my age is greater than 10, my pet is equal to cat. This evaluates true as both parts on either side of the AND operator evaluate true. And that's it for this lesson. We now know everything we need to start covering statements. And just to recap, the two values of the Boolean data type are true and T and capital F. The 6 comparison operators are equal to, not equal to, less than, greater than, less than or equal to, greater or equal to. The equals operator is the comparison operator. This has two equals. Well, the equal sign operator is the assignment operator. It's used in assignment statements like spam equals the value 42 to the variable spam. 3 Boolean operators are AND, OR, and NOT. And is true if both sides are true, otherwise it's false. OR is true as long as anything is true. It's only false if both of them are false. And the NOT operator simply evaluates to the opposite Boolean value. Welcome to Lesson 5, which roughly covers pages 38 to 45 of the Automate the Boring with Python textbook. Now that we know about Boolean values, comparison operators, and Boolean operators, we can start looking at flow control statements. The simplest flow control statements are if and else. Open up a new file editor window by clicking on File, New File, and enter the following code. Name equals Alice, if name equals Alice, colon, print, hi Alice, and then go back to the original indentation and type print done. I'm going to save this as ifexample.py and press F5 to run it. You can see that this code prints out hi Alice and done. So let's take a look at the if statement Here's a flowchart diagram for it. The expression in the if statement is called a condition. Condition is just a name for an expression in a flow control statement, but technically a condition and an expression are the same thing. If the condition in an if statement evaluates true, the execution enters the indented code that follows. If the condition is false, the execution skips the indented code. There's a great visualization tool at pythontutor.com that can show us what's happening in this program. I'm just going to copy and paste this program and then click Visualize Execution. We can click forward to step through the program one line at a time. So first, Alice is assigned to the name variable, then the condition is and it does evaluate to true, so the execution enters this indented code and prints out, "Hi Alice," and then finally it leaves the block of this indented line of code and executes print done. So let's go back and change this slightly. I'm going to change this so that Bob is assigned to name. You can see that this condition evaluates to false now, so the line of code after it is skipped, and only done is printed. This indented code is called a block. A block is made up of lines of code that are indented at the same level. The indentation is how Python tells what part is inside the if statement's block and what isn't. A block begins when the indentation increases and ends when the indentation returns to its previous level. Blank lines are ignored for the sake of looking at what is in or not in the block. So this is how you can tell that print "Hi Alice" is in a block, because its indentation is increased compared to the previous line. Here's a small game program that I wrote. You don't have to pay attention to the code, just look at the indentation and you can tell where blocks begin and end. Until here, the indentation is increased, so this has started a new block. And then the indentation returns back to normal here, so that's the end of the block. This is the complete block. Right here you can tell a block has started, and then the indentation has increased again on this line, so this is a block inside of this block. And then the indentation returns to its previous level, so this continues on with the previous block, and then the indentation returns back to 0 here, so that's the end of this block. This is all one block, it just contains another block inside of itself. And then looking on, you can see this is also a block. It just contains this block, this one line block here, and this one line block here. And then another block begins right here. Blocks are also sometimes called clauses, but just like how condition is just another name for an expression, they're the same thing. And as a nice reminder, new blocks begin only after statements that end with a colon, like in the if statement in our previous program. You can also check it out right here. Here's a colon, and it begins a new block here. Here's another colon in this statement. It begins a new block. This colon shows a new block is starting. In our name equals Alice example, if the condition was false, nothing happened, but we can use an else statement so that code runs specifically when a condition is false. Let's create a new program and type in the following code. Password equals swordfish. If password equals swordfish, then print access granted, and hit backspace to get rid of that indentation, and type else colon print long password, and save this as if example. In plain English, this reads as if password is equal swordfish, print access granted, or else print wrong password. Let's copy and paste this into the online Python tutor tool. If the condition is true, then the if block is executed, the else block is skipped. But if we set it so that the condition will be false, then the if block is skipped and the else block is executed. One and only one of the blocks will be executed. So the flowchart for this program would look something like this. You can see that any path from start to end will go through one and only one of the blocks. So with if-else statements, one of two blocks is executed, but you might have a case where you want one of many possible blocks execute. The elif statement is an else-if statement. It lets you provide as many additional conditions to check as you need. Open a new file editor window and enter the following code. Name equals Bob, age equals 3000, if name equals Alice, print hi Alice, elif age is less than 12, print you are not Alice, kiddo, elif age is greater than 2000, print unlike you, Alice is not an undead, immortal vampire. Elif age is greater than 100, print you are not Alice, Granny. Save this as if elif example, and then let's run this program. We can copy and paste this into the online Python tutor tool to see what exactly is happening. Here, the string Bob is assigned to name, the integer 3000 is assigned to age, and we're at the if statement. This condition is checked and it's false, so it skips that block. Then this else statement has its condition checked. It's also false, so we skip that. And then here, this is the first true condition that we found, so the execution enters inside of this block. Prints that out, and then it just skips all of the other conditions. You can have as many elif statements follow an if statement as you need, but the order of the elif statements does matter. The execution enters the first block that has a true condition. The rest of the conditions won't even be checked. You can also add an else statement to the end of the chain of elif statements. The else statements block will execute if all of the previous conditions have been false. One last thing about flow control statements. Sometimes you might see code like this. This condition is kind of weird. The name variable is set to whatever the user has typed in, but input will be returning a string value, not a Boolean true or false value. But the reason this code works is that the conditions can use truthy and falsy values. Now, for strings, the string is a falsy value. If a condition evaluates to the blank string, it's considered to be the same as the false Boolean values. All the other non-blank string values are truthy values. Let's try running this code. Enter a name, I can type in Alice, and it says thank you for entering a name. Since a non-blank string like Alice is truthy, then this was considered to be a true condition, so it entered this block of code. But if I run this again and enter nothing, the blank string is considered a falsy value, so this condition is considered to be false. And so this block of code was executed. While this code works and it's a shortcut, in general it's better to be more explicit. You should change this line to be something more like, if name does not equal the blank string. For integers, the value 0 is the falsy value and every other integer value is truthy, and the 0.0 floating point value is false, everything else is truthy. But you can use the bool function to return an equivalent Boolean value of whatever value you pass it. This is kind of like the string and int functions that we've seen before. So if we pass 0 to bool, we can see that's a falsy value. Bool returns false. But if we pass any other integer, it returns true. We can do this with string values as well. Hello is a truthy value, whereas the blank string is a falsy value. To recap, an if statement can be used to conditionally execute code, depending on whether or not the if condition is true or false. In elif, that is, an else if statement, can follow an if statement, and its block executes if the condition is true and all the previous conditions have been false. An else statement comes at the end. Its block is executed if all the previous conditions have been false. And finally, the values 0, 0.0, and the empty string are considered to be falsy values. When used in conditions, they're considered to be the same as the false Boolean values. You can always see for yourself which values are truthy or falsy by passing them to the bool function.